Okay, so welcome to the beginning on a series of mechanical rigidity for 3D printers. We'll start off with a cube design, the classic cube. First thing, this is what we call parallelogramming. Just thing you can see. We're using tape and straws because that's really obvious. You can see things like if the piece is bending, and it's really easy. I did put this together in like 5 minutes, as opposed to a 3D printer, which I'll show you over here, which took a day. So anyway, so this is what we call parallelogramming or shearing. The top face, you can clearly see, moves both forwards and backwards in the thing, and side to side, but also importantly there's something twisting as well. All right, this is your basic, your average cube with plastic corners, and in some cases, if you've got 20/20 extrusion and you're doing like a 400mm frame because you've got a 300mm print bed in it, the corners are just going to be totally inadequate. So what we're going to do is demonstrate a couple of ways in which you can beef this frame up and make it absolutely rigid using paper. And tape. I love tape. It's so simple to do. Right, first thing, let's demonstrate a diagonal brace. One. Now this would represent either a standard cross brace, 20/20 extrusion, or any other material. I think. Now watch this, okay? That way, no problem, but when you push it, bends. Now that means that if this is 20/20, you're probably okay, because it won't bend under pressure there. But if it was a panel, you'd be in trouble. All right. So how could we deal with this cheaply? I know. Let's put another one on. Right. 1, 2. Okay, right. So, ta-da! It ain't going nowhere. And that is a very low cost way, and you could actually, wouldn't recommend it, but if it was beefy enough, you could probably get away with a high tensile steel wire. And I have actually seen printers which have done this. They've got a couple of things, but you have to put it under really quite high tension, take all the slack out of it, and just make sure that you're happy with it. But 3mm MDF or hardboard or anything, basically, as long as it's got the double bracing, you're fine. Now, if you want to go for the ultimate sort of thing. By the way, I have to say it again. I did say it on the Wikipedia page on the Reprap thing, but the Ultimaker 2 really is absolutely astounding design. Well done, guys. And it's basically made entirely of panels. So let's take the same principle that we've got on that cross piece and just put 1, 2, dunk. Just it takes me back to our days with Blue Peter. Alright. Watching Blue Peter, I love that series. They did it live too, which was fantastic. Okay, so again, that's because I haven't tightened it out. You can see the shifting in that because I haven't made it completely tight. Now here, this is where if you're going to use this for rigidity, damn it. Let's try and get that a little bit more. That's better. But you can see here that can flex. Right there, the panel can obviously flex. So just to sort that out, Alright, and stop flexing, you would need a screw and bolt attaching it to the frame or to the other panel on all 4 sides. Alright, so that's now no longer going to flex there. So now we've got 2 rigid sides, but you can still do, let me put it this way, the twisting. You can still twist it and you can still flex it, but what you can't do is you can't do that and you can't do that. I wish I'd put the thing tightened that up properly in the corner anyway. So let's do, I'm not going to brace them on the things, but let's put all, let's do all 6. 1, so I'm not going to put it on there like I did with the other one with the, you know, in, what was it, how many, 8 places per panel. It's ridiculous. Yeah, I know it sounds, you know, like, oh, it's a cube design, but it's actually, to get it properly rigid is bloody staggering. It's like, you know, you've got 8 attachment points per face, and there's 6 faces. That's 48 attachment points. And ideally, if you're going to use it for attaching things in the corners, you should also be having 2 per corner here per face. So 1, 2, 3, 4, 5, 6. So that's a thing, because that will allow you the parts in those corners. The parts in those corners will not rotate. I'm so sorry I haven't done the Blue Peter thing of, and here's one we made earlier. We are literally making this as we go along. Okay, so still, that stops there, and it's also okay. So let's go focus on this face here. Watch it. This face does not move forwards, and it also does not move sideways. But this corner, so that corner is totally rigid. Just this corner only is completely rigid. The rest of them, you can see that one twists. Okay, so fix that. More pieces of paper. Now, the staggering thing about the Ultimaker is that it is purely made from the panels, the rigidity, but it is, I think it's 5 attachment points per face. The rigidity is entirely from the panels. There is no need for extrusion along the edges, and unfortunately we can't, because it's got taped up. We won't actually be able to take the straws out of here to show you that, but I think, okay, alright, so right, finally, now we have 4 corners that are definitely not going anywhere. Alright, but the top can still shear sideways. Alright, this is the final one, and this is the point at which we will have, at last, a rigid box. Tighten them up a little bit so that it doesn't. It's actually quite useful that that some of these are a little bit loose, because that shows you the flex that is inherent in the things, which is down to the fact that okay, so I'm pulling that corner tight in the thing. Right, and finally, a rigid box. Yeah, made out of paper. Is that awesome? All right, so now, obviously you can't get in it. All right, so let's do the Ultimaker thing and cut the holes in the middle for access panels. Yeah, it's tape. Now the reason why I'm doing this is to demonstrate to you the effectiveness. I'll just tear it down. There we go. Effectiveness of just having these parts, these panels with open holes in them. Okay, so now can you see the lack of the fact that I didn't properly tension it is beginning to show. Which is good. But if you had 3mm acrylic, for example, that's going to minimize. But it is important to make sure that you firmly attach the acrylic or the MDF or whatever it is to the rails. If there's any lack of bite in between your panel and the extrusion that it's on, or the other panels, and more specifically the other panels, it is going to flex. Now let's expand that and see how far we can push this. Dum, dum, dum. Da, 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 da. Snip. Okay, so it's still. Can you see that it's pulling on here when you pull it outside and thing? But it is still actually working. That is still. I mean, it's not perfect, but can you see the when you bow it, this part can bow out. So that's why it's important to have the attachment point on here, and for this surface to be the thing. Now it's important that you keep the corners curved. Don't go too close when you make do panels like access panels like this, an open frame thing to get at the actual printer. Make sure, for goodness sake, that you don't create panels that are too close down here. That's 30mm is really about the limit of what. No, it's torn. That's exactly what you don't want to happen. All right. So that's because we are using paper, but it's actually a very good illustration of the kind of forces and stresses that the thing will be put under. But also it will be bowing like this. So if you have a large span, you want bracing on the inside to make sure that this thing can't bow like this. So yeah, I don't believe I need to cut holes in any of the other ones, but obviously you can do that as many times as you like. And there's another piece of paper gone in the corner. Broken in the corner. Oops. Yeah, you can see that's bowing outwards as it flexes. Under there. Yeah. Thank you very much.